Hello, this is the lecture for quadratic equations. All right, what is a quadratic equation? Well, the simplest way to think about a quadratic equation is it's one that has the highest exponent, where the highest exponent is 2. Okay, we can write a quadratic equation as an equation or as a function, right? If we're writing a quadratic equation as a function, we would just use function notation, f of x, and it would need to take this form ax squared plus bx plus c when it's in its standard form. This is referred to as the standard form. A few qualifications on this: a, b, and c need to be real numbers, okay? And then a cannot equal 0. All right, just a note, the domain of a quadratic function is the set of all real numbers. So there are no limitations on the domain of a quadratic function. Recall that the domain is all the values that x can take on, or all the values that the independent variable can have. All right, when we're solving a quadratic equation, it may appear in any multiple different forms, but we always want to write a quadratic equation in its function form before we solve, or set that equation equal to 0. So 0 is on one side of the equation before we begin solving. All right, so let's look at this example here. Let's see if we could write this equation here, 3x minus 2 equals x squared, as a function. Let's put that in function form. Right? So let's see. We know it's quadratic because the highest exponent is 2. But if we want it in function form, we need to put all the terms on one side. All right? So let's see. Why don't we just move that 3x over to the right and move the negative 2 over as well. We'll move that negative 3x over by subtracting it from both sides. And we'll move that 2 over by adding it to both sides. So then we end up with x squared minus 3x plus 2 on the right-hand side, and we can call that our function. We'll call that our f of x. Okay? So that's the function form for that quadratic equation. And then, of course, when we begin solving it, we want to set it equal to 0, so we'll want to substitute 0 in for that output. Okay, there are several methods that can be used to solve a quadratic function or a quadratic equation, right? If we're solving an equation, or we might say we're finding the zeros of a quadratic function. 2 methods are listed here. Let's list them all out. There are 3 methods, so let's look at them all at once. The 3 methods that we might use, the first method would be factoring. Okay, in this case, we would want to factor factor the quadratic expression completely. Then we'll employ the zero product principle to solve for the variable. A second method would be to use the quadratic formula if we have a prime quadratic expression, or a quadratic expression that cannot be factored. We need to use the quadratic formula. And then sometimes, not that often, but sometimes there's a third method that is helpful. It's a little bit easier. If a quadratic function is in a certain format, we might use the square root method to solve it. The square root method only works, or is only helpful, though, if there's no middle term or no b term in the quadratic function, or if it's not simplified and one side is a perfect square. More about that later. Let's look at some examples using the first method. Let's look at some examples of solving quadratic equations by factoring. All right, in this first quadratic equation, it's already set equal to 0. That's very nice. So then to solve this, what we want to do is factor this trinomial, and then we'll use the zero product principle to solve for x. All right, this is a trinomial that has a leading coefficient of 1, right, or just x squared as its first term. So all we need to do to factor that is look for factors of -6 that add to -1. All right, the factors of -6 that add to -1 are going to be -3 and +2. Right? -3 times +2 is -6. Then -3x plus 2x is going to be -x. All right, so there's my trinomial factored. Now let's employ the zero product principle and solve for x. To do that, we want to take each one of these factors and set it equal to 0. So we want to say x minus 3 equals 0, or x plus 2 equals 0, and solve both equations. If x minus 3 equals 0, when we add 3 to both sides, we see that x equals 3. If x plus 2 equals 0, when we subtract 2 from both sides, we see that x equals -2. So there's our two solutions to the quadratic equation. And quadratic equations often have two solutions, not always, but they often have two solutions. We should always check the answers just to make sure. How do we check those answers? I'll just plug them back into our original equation and make sure they're true. So if x equals 3 and I plug 3 in for x, then 3 squared minus 3 minus 6 should equal 0. Does it? Well, 3 squared is 9. And of course, 9 minus 9 is 0. So I know that answer is correct because it satisfies the equation, right? Or when we plug that value of x equals 3 in there for x and simplify, we see that it is true. The equation is true. All right, let's check that -2. If x is equal to -2, then -2 squared, have to be careful with your parentheses here, right? -2 squared minus -2 minus 6 should equal 0. Does it? Let's see. -2 times -2 is +4 minus a -2. That's going to be +2 minus 6, and 6 minus 6 is definitely equal to 0. All right. Look at the second example over here. Can we solve that one by factoring? Well, it's not in its standard form yet, right? It's not in function form, or it's not, all the terms are not on one side of the equal sign. And we have to do that. We have to set this equation equal to 0 before we can solve. So we're going to need to put that in the correct form first. So let's move that -x over to the left by adding it to both sides. Okay? When we add that x to both sides, on the left, then we have x squared plus x equals 0. Now that it's set equal to 0, we can go about factoring it. Well, there aren't 3 terms here, right? Well, or maybe we think about that third term as being equal to 0, right? The c term equal to 0. So we don't necessarily, we're not factoring a trinomial here, but look at this. There is a greatest common factor, right? Both x squared and x are evenly divisible by x. So we can factor that. We can factor out an x. When we factor out an x, what we're left with, x squared divided by x is x. And then, of course, x divided by x is just 1. So x times x plus 1 equals 0. All right, now when we employ the zero product principle, either x equals 0 or x plus 1 equals 0. Well, x equals 0 is one of the solutions, but if x plus 1 equals 0, we would want to subtract that 1 from both sides to solve for x, and we would see that x has to be -1. Okay, and we can check our answers. Well, 0 squared is definitely equal to -0. This is no value equal no value. And then if x is -1, -1 squared is +1, and then the negative of -1 is also +1. So our answers do check. All right, so there is a little bit of a procedure. I guess there's a little bit of a procedure that we can follow here, right? When we're solving a quadratic equation, let's see if we can start writing steps of what we've been doing. Okay, let's see if we can start writing steps. In fact, let's do another example, and maybe we'll write the steps as we solve the equation. All right, so look at this example. 2x times 2x minus 7, in parentheses, is equal to negative 12. Well, at a first glance, that one doesn't look quadratic, does it? Because I don't see an exponent of 2. But the first step really is to simplify this equation. The first step in solving here is to simplify the equation, excuse me, which means that I have to distribute that 2x. So when I distribute that 2x times 2x, of course, is 4x squared. And then 2x times negative 7 is negative 14x, and it's still equal to negative 12. Now that I've simplified, it's turned quadratic, right? So if we're writing our steps out, let's say to solve a quadratic equation, the first thing we might have to do is simplify. Simplify if needed. Okay, so we did that. Now what would be the next thing that we need to do here? Whenever we're solving a quadratic equation using factoring or the quadratic formula, we want to set the equation equal to 0. All right, so let's move that negative 12 over. We'll add 12 to both sides. And when we add 12 to both sides, we'll be left with 0 on the right-hand side. Okay, so 4x squared minus 14x plus 12 is equal to 0. All right, so that was the second step. Let's write that down. The second step would be to set the equation equal to 0. All right, now what do we need to do here? Well, we have a trinomial, right? The leading coefficient is not 1, the A term here, A is not 1. But, so I could use the AC method and start factoring here, but I'm going to be dealing with large numbers, right? Because 4 times 12 is 48. I'm going to need to look for factors of 48 and add to negative 14. So I could simplify this by factoring out a greatest common factor. These three terms are all evenly divisible by 2. So if I factor a 2 out, I'm going to be left with smaller numbers to deal with, and that's going to make my factoring easier, right? So 4x squared divided by 2 is 2x squared. Negative 14, oops, I left off my x there. Negative 14x divided by 2 is negative x, and then 12 divided by 2, of course, is 6. Okay, and since we're solving here, we can go ahead and divide out that 2 and just kind of forget about it, right? Because 0 divided by 2 is just 0, 2 divided by 2 is just 1, and we have an easier equation to solve now. 2x squared minus 7x plus 6 equals 0. All right, so that step, if we're writing steps, that third step here, we'd say factor out the greatest common factor, if there is one, right? Or the GCF, if possible. There isn't always going to be a greatest common factor, but if there is, we should factor it out. It'll make our future steps easier. Okay, so factor out the GCF if possible. We can then divide it away when we're solving. So let's see. If possible, then divide away. Divide away. All right, and we don't have to deal with that GCF anymore if it's just a constant. All right, so now let's see. we're going to need to factor the trinomial. There is no further greatest, we've got the greatest common factor out. We need to factor this trinomial now. I think we'll go ahead and use the AC method, okay? So the AC method requires standard form or order of decreasing exponent. We're in that form here, okay? So that means our A is 2, our B is -7, our C is 6, right? Using the AC method, we can say that A times C is equal to 2 times 6, or 12. Okay? So now we want to find factors of 12 that add to -7. Well, the factors of positive 12 that add to -7 are going to be -3 and -4, right? Because -3 times -4 is 12, -3 plus -4 is -7. So those are the factors I want. So let's split this into 4 terms now and then factor by grouping. We're going to split that middle term. So we'll have 2x squared minus 3x minus 4x plus 6 equal to 0. All right, let's group them and pull the greatest common factor out of each group. All right, in our first group here, the greatest common factor is going to be x. So let's factor that out. X. So 2x squared divided by x is 2x, and -3x divided by x is -3. Okay, so that's x times 2x minus 3. And then the greatest common factor over here in the second group is 2, but I want to factor out a -2 so that I've got a 2x minus 3 left behind. So I'll factor out that -2. We've got 2x minus 3 left behind then, right? Because -4x divided by -2 is 2x. 6 divided by -2 is -3. Okay. So now I can factor out this 2x minus 3. And what's left, once I factor out that 2x minus 3, what's left is the x minus 2. And that's still equal to 0. Okay, so wait, we did a step here, didn't we? Let's write that down. Factor out the greatest common factor. The fourth step then is going to say factor completely. Or maybe factor the trinomial. Okay, might need to do the AC method there, might not. Okay, so I've got it factored. All right, now we can continue solving. Let's do it up here since we're out of room. If 2x minus 3 times x minus 2 is equal to 0, then the zero product principle tells us that either 2x minus 3 equals 0 or x minus 2 equals 0. Okay, if 2x minus 3 equals 0, I don't know why I wrote parentheses, we don't need these. We want to solve for x. Let's add 3 to both sides. So then 2x is equal to 3, and we'll divide both sides by 2. 2's divide out, so x equals 3 halves. There's one of our solutions. If x minus 2 equals 0, we'll just add that 2 to both sides, and we'll see that x equals 2. And there's my 2 solutions. All right, so that last step that we took here was use the zero product principle to solve. Okay, and then of course the last step would be to check your answers, make sure you didn't make a mistake. I am not going to check on this to save time. We're going to just move on to the next method for solving. All right, so we've talked about solving, the first method, solving by factoring. That third method that I mentioned, I said you can't always use it. Let's look back at those methods. You can't always use it, but when you can, It works very nicely. That third method, that square root method, let's look at that now. And then lastly, we'll look at the quadratic formula. With the square root method, it only can be used if you do not have a middle term, like in this example here, but this has just got the squared term and the constant. It does not have the term with just the variable in it to the first power. So the middle term is not there. There's no b value when it's in standard form, right? Let's put that up there. The standard form is ax squared plus bx plus c. Okay, if there's no b term there, the square root method works nicely. The other time that the square root method works nicely is if one side of the equation is a perfect square. In the second example down here, look at this. That side of the equation is a perfect square. All right. So how do we solve these? Well, using the square root method, if there's no middle term, instead of having it equal to 0, what we're going to do is we're going to have the square part, the perfect square, all by itself. So we're going to add 18 to both sides. So we have p squared equals 18, and then we're going to take the square root of both sides. Let's finish it up there. Now, we have to be careful of something. Now, the square root of p squared, that's just p, right? P equals the square root of 18. We have to be careful here, right? Some of you might have noticed there's something I didn't do. What didn't I do? Whenever we're solving with the square root method, we're solving for this variable here, we have to remember that when we take the square root of both sides, that the right-hand side, it can be either plus or minus the square root of what it was before. So we want to be careful not to forget that. There's going to be two solutions here. And then one more thing we want to do is we probably want to simplify that radical, if that can be simplified, right? And this one can because 18 is 9 times 2, right? So this will simplify to 3 square roots of 2 and negative 3 square roots of 2. Okay, on the second example down here, we don't need to move anything around because we already have a perfect square on one side of the equation. So we just want to take the square root of both sides, and we just have to be very careful not to forget our plus or minus, right? So then the square root of x minus 3 squared is just x minus 3. I think I'm just going to write it over here. And it's going to equal plus or minus the square root of 16. Okay, the square root of 16, of course, is 4. So x minus 3 then is going to be equal to plus or minus 4. And all we have to do is solve for x. Now, really, what we're going to do when we solve for x here, I mean, I could keep it here. I could say, well, we're going to add that 3 to both sides. So then x is equal to plus or minus 4 plus 3, right? That's kind of weird. I probably want to put my answers separately, right? If I'm saying x is plus 4 plus 3, x equals 7. If I'm saying x is minus 4 plus 3, x equals negative 1. So we have two solutions there for x. All right, and then the last method for solving a quadratic formula, or solving a quadratic function, is using the quadratic formula. With the quadratic formula, it's kind of a pain in the neck. We don't like to use it unless we have to, but it is what we must use when the quadratic expression is prime, or when it cannot be factored. All right, to use the quadratic formula, you want to make sure your equation's in standard form, right, or function form. You want to set the equation equal to 0, put the terms in order of descending exponent, okay? And once you've done that, then you can solve for x. The value for x that's going to make that equation true is going to be negative b, that's the coefficient in front of the x, right? Plus or minus the square root of b squared minus 4 times a. A is the coefficient in front of the x squared, right? Times c. C is the constant out here at the end. And then that whole thing will be divided by 2 times a, the coefficient of the x squared term. All right, let's look at some examples of solving quadratic equations using that quadratic formula. By the way, this is a memorizer. You need to memorize this formula. I can't carry a tune, so you don't want to hear me sing, but there are some easy ways to memorize this. If you Google quadratic formula song, there's some fun, cute things that people have put together and ways that help you memorize that equation. All right, in this first example, we always want to ask ourselves, is it in standard form first? This first example is x squared minus 5x minus 9 equals 0. Okay, it's all set equal to 0, and it's in the order of descending exponent. Okay, I might try to factor that, so I would look for factors of -9 that add to -5. Excuse me, and I would find that there are none. There are no factors of -9 that add to -5, so I would say, well, I can't solve that one by factoring, so I'm going to have to use the quadratic formula. All right, let's write it up here so we have it in front of us. X equals -b plus or minus the square root of b squared times a times c, and then that whole thing gets divided by 2a. All right, in our equation here, a, the coefficient for the x squared term, is just 1. B is -5, and then c is -9. All right, so we want to plug these values into our quadratic function and solve. So x then is going to be equal to -b. Be careful with these negatives, right? So that's going to be the negative of -5 plus or minus the square root of b squared. It's going to be -5 squared minus 4 times a is just 1, times c is -9, all over 2 times a, 2 times 1. Okay, let's simplify that a little bit. The negative of -5 is +5 plus or minus the square root, and -5 times -5, or -5 quantity squared, is +25. -4 times -9 is +36. So this is going to be 25 plus 36. Here we'll write an extra 25 plus 36 all over 2 times 1, or just 2. Simplify one more step here. 5 plus or minus the square root, 25 plus 36 is 61, all over 2. Okay, now, you know, that's fine like that. My Open Math may ask you to put these in as 2 separate answers. If you see the word exact, give an exact answer. If it says that, you want to leave your radical. If it doesn't, you might be able, you could estimate a decimal. So as 2 answers, this is going to be 5 minus the square root of 61 over 2, or 5 plus the square root of 61 over 2. As a decimal approximation, we'll see what that is. 5 minus the square root of 61 divided by 2. That's -1.405, we'll say. Approximately -1.405. And then 5 plus the square root of 61 divided by 2 is 6.405. Okay, so if my Open Math says give an exact answer, leave your radicals. Leave your radicals. If it doesn't, you can estimate the decimals. If it wants you to estimate your decimal answer, it's going to tell you how many decimals to include in your answer. Okay. One more way that you could write this as an exact answer, wouldn't have to, but one more way that you could write that would be 5 halves minus the square root of 61 over 2, or 5 halves plus the square root of 61 over 2. I very seldom would think that that would be necessary. Oh, there's another example here. Let's look at this one. All right, this one is not in its standard form yet. It's not there, right? So we need to set that equal to 0. We'll need to subtract that 6 from both sides. So then x squared minus 10x minus 6 equals 0. Okay, I might try to factor that. I might look for factors of -6 that add to -10, but there aren't any. There aren't any. So my a then is 1, my b is -10, and my c is -6. Okay, let's plug that into our quadratic formula and see what value of x makes that equation true. All right, so x then is -b. That's going to be the negative of -10 plus or minus the square root of b squared. That's -10 squared minus 4 times a is 1 again, times c is -6, all over 2 times a, or 2 times 1. Let's simplify that. Negative of -10 is +10 plus or minus the square root of -10 squared, that's 100. -4 times -6 is +24. So this becomes 10 plus or minus the square root of 124 over 2. All right. Now, don't you want to just simplify that and say the 10 divided by 2 is 5? Yeah, I kind of do too, but you can't do it when it's written like this, can you? Because in order to divide the 10 by the 2, I needed to be able to divide that square root of 124 by 2, but I can't because the 124 is under the radical. But I might be able to simplify that radical. Let's see, are there any perfect squares that are factors of 124? Let's see, how about 4? Yep. 124 is 4 times 31, right? And the square root of 4 is 2. So this can simplify to 10 plus or minus 2 square roots of 31 all over 2. Now I can divide out that 2 because I can do it with both terms in the numerator. Look at this. 10 divided by 2 is 5. And then 2 divided by 2 is 1. Okay, so this simplified down to 5 plus or minus 1 square roots of 31, or I'll just say the square root of 31 divided by 1. I don't need to divide that, right? And I could put the decimal approximation as well if I wanted to. All right, sometimes when we're solving a quadratic equation, we get a complex solution, right? We end up, because that quadratic formula has an even radicand in it, you have or an even radical in it, an even root, you have the possibility for a negative radicand, right? So let's put it up here again so we can see it. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. Well, what if b squared minus 4ac ends up being a negative value? And it can, right? It can be a negative value. Well, when that happens, we have to introduce we have to introduce our friend, the imaginary number. Let's look at this example here. All right. So if we want to find all the zeros of this equation, or we want to solve for z, another way, finding the zeros is another way of saying I want to find the value of z that makes this equation true. Usually when I say find all the zeros, I'm referring to a function. But if I wanted to solve this equation, let's see, it's not in the right form yet, right? It needs to be set equal to 0. So let's move that -8z and that -19 over. We'll add that to both sides. We'll add the 8z and the 19 to both sides. Okay, and then we'll have z squared plus 8z plus 19 equal to 0. Here we go. Okay, I might try to factor that, and I would very quickly find that there are no factors of 19 that add to positive 8, and I'd say, okay, I'm going to have to use the quadratic formula to solve for z. Okay, so z, our variable is not x this time, it's z. So z then is going to equal negative b. What was my b? Was it negative 8? Oh no, we moved it over, right? Okay, let's write them out. A was 1 again. B this time is positive 8 or 8, and c is 19. All right, so then my variable z is going to be equal to negative b. That's negative 8 plus or minus the square root of b squared. That's 8 squared. 8 squared. Minus 4 times a, that's 1, times c, that's 19, all over 2a. Or 2 times 1. A is 1. That's 2 times 1. Okay, let's simplify that. Negative 8 plus or minus the square root of 8 squared is 64. 4 times 19 is, let me use my calculator, is 76. All over 2. Let's see, that's 64 minus 76. Oh, that's negative 12, isn't it? Interesting, we have a negative radicand. All right, so negative 8 plus or minus the square root of negative 12 all over 2. And I can't do anything more with this. I can't simplify this any further until I deal with that non-real number there, with that non-real number. Okay, so I'm going to take the shortcut. I'm going to stick an I out front and drop the negative. So this then becomes negative 8 plus or minus I times the square root of 12 over 2. Okay. I really want to simplify that negative 8 divided by 2, but I can't do it because 12 is under the radical. I can't say 12 divided by 2, but I might be able to simplify that radical so then I can divide out the 2. Let's see. Does the square root of 12 simplify? Oh, it does. It does. 12 is 4 times 3. The square root of 4 is just 2. Okay? So, I times the square root of 12 will simplify to 2i times the square root of 3. Right? Because 12 is 4 times 3, and the square root of 4 is 2. So I can bring that 2 out. Divided by 2. Now, I can divide out that 2 because both terms in my numerator are evenly divisible by 2. Okay, now I can divide it out. Negative 8 divided by 2 is negative 4, and then of course 2 divided by 2 is just 1. So this will simplify down to negative 4 plus or minus 1i, or just I, times the square root of 3. All right, and there is my answer in exact form. We don't pass the decimal there. Close to that. All right, well, let's close out this lecture with some applications. There's really no point in learning this material if we can't apply it to solve problems, right? So let's look at this first one. This one's just kind of a fun application, a way to think about and review a few standard formulas. What's it saying here? The length of a rectangle is 3 inches longer than its width. Okay, if the area is 40 square inches, what are the dimensions? The dimensions of that rectangle. So what are the length and the width? Well, anytime that you're solving an application and it lends itself to a diagram, you should draw the diagram. So let's do that. Let's draw a rectangle. Maybe we'll put it up here. Let's put our rectangle up here. There's a rectangle. Okay, and they're telling us that the length of this rectangle is 3 inches longer than the width. All right, well, we'll make this side here the width, we'll make this side here the length, but the length is 3 inches longer than the width, so I could write the length as W plus 3. Okay, now there's my diagram. Now they're telling us that that area is 40 square inches. What is the formula for the area of a rectangle? the area of a rectangle is equal to the length times the width, okay? So for this particular application, if area is length times width, then for this application, they're telling me the area is 40. I can say 40 is equal to length, which is W plus 3, right? W plus 3 times the width times W. All right, well, we can simplify that by distributing the W. And when we do that, we see that 40 is equal to W squared plus 3W. Hey, look what happened. That equation just turned quadratic on us when we simplified. Like the highest exponent is 2. So that means to solve it, we should set it equal to 0. Okay, so let's subtract that 40 from both sides. When we subtract that 40 from both sides, we'll have 0 equal to W squared plus 3W minus 40. All right, and let's see, will this factor? Are there factors of negative 40 that add to positive 3? I think so. Let's see, how about positive 8 and negative 5? 8 times negative 5 is negative 40. 8 plus negative 5 is positive 3. So this will factor. I don't have to use the quadratic formula here. Let's factor it. I'll factor into W plus 8 times W minus 5. All right, now that it's factored, we can use the zero product principle. Okay, so we'll say either, I'm going to do it up here. I'm going to move over. Either W plus 8 equals 0 or W minus 5 equals 0. If W plus 8 equals 0, when we subtract 8 from both sides, we see that W equals negative 8. If W minus 5 equals 0, add 5 to both sides, and we see that W equals 5. All right, well, we often get two solutions when we're solving a quadratic equation. We've seen that over and over. But does it make sense in the context of this problem here? Can we have the width of a triangle equal to negative 8? Oh, no, that makes no sense, right? So we need to throw this answer out. That one doesn't make sense. That's actually going to be outside of the domain that's being implied by the context of our problem here. All right, we cannot have negative widths of a rectangle, so we throw that one out. So W then is equal to 5. We know the width. What were the dimensions? Well, if the width is 5, the length is W plus 3, or the length here is going to be 5 plus 3, or 8 inches. Inches, right? I mean, inches, yeah, we're inches. 5 inches by 8 inches then is going to be the dimension of that rectangle. Okay, there's a second question here. The second question is saying, what is the length of the diagonal? Well, recall that the diagonal of a rectangle is the one that connects the corners. There's two diagonals here, but they're going to have the same length. Here's one diagonal. There's another one I could draw here. But since they have the same length, I'm just going to do the one. I don't know what that length is. Let me call it D for diagonal. Okay, D for diagonal. Well, how can I find the length of that diagonal? I'm going to need to remember another common formula. If we're considering this triangle here, I'll draw that in yellow. If we're considering this triangle here, it would be a right triangle because all the corners of a rectangle are right corners. So if I look at that yellow triangle, it is a right triangle. What do we know? Can you think of any equations, any formulas that you know that apply to right triangles? How about the Pythagorean theorem, right? The Pythagorean theorem says, some of you maybe learned it this way. Let's write it, Pythagorean theorem. Okay, the Pythagorean theorem, some of you might have learned a squared plus b squared equals c squared. But what the Pythagorean says is that one leg of a right triangle squared plus the second leg of the right triangle squared is equal to the hypotenuse of the right triangle squared. Okay, so for our cases here, it's going to be the length squared plus the width squared. So if the width will be the same in a rectangle. So the length squared plus the width squared equals the diagonal squared, right? Or in our case, we know the length and the width, right? We know that the length is 8 inches and the width is 5 inches. So we can say 8 squared plus 5 squared is equal to that diagonal squared. 8 squared, of course, is 64. 5 squared, of course, is 25. Still equal to b squared. 64 plus 25 is 89. Well, if 89 is the square of that diagonal, if I take the square root of both sides, I can see that the diagonal then is going to be the square root of 89. Now, normally, when solving by the square root method, I would want to say that it's plus or minus 89, but the diagonal of a triangle cannot have a negative value. So in this case, I don't need that negative because it doesn't apply. In context, it needs to be excluded from the domain. Square root of 89 is kind of odd when we're thinking about the length of a diagonal, so I might approximate that as a decimal. Let's see what it is. The square root of 89 is approximately 9.43, and our units here are inches. Okay? Kind of a fun little application. Let's look at one more. Here's one that involves population. Right? The population of a city in thousands of people, okay, so the population in thousands of people, it can be modeled by this function, P of t equals 0.07 t squared plus 4t plus 110, where t is the number of years since the year 2000. Since the year 2000. All right, so this is a function. We're in function notation. Population as a function of years since 2000 is equal to this expression here. Our first question is saying, what is the population in the year 2015? In the year 2015, or what was the population in the year 2015? Well, let's see. Years since 2000. Well, t here is going to have to be years since 2000. So t is going to have to be the 2015 minus the 2000, or 15. So what I want to find here is the population 15 years after the year 2000, or p of 15 in function notation. Okay, p of 15 is going to be 0.07 times 15 squared plus 4 times 15 plus 110. I'll put that in a calculator to see what that's going to be. 0.07 times 15 squared plus 4 times 15 plus 110. 185.75. Does it make sense to have a decimal here when we're dealing with population? Well, it wouldn't if it was the number of people, but look, this is in thousands, So we would say 185.75 thousand, or that's kind of awkward, isn't it? It'd probably be better, people, it'd probably be better just to multiply times 1,000, move that decimal over, and say that that's 185,750 people. Both would be correct as long as I labeled it properly. 185,750, that's a comma, people. Right? So 185.75 thousand people, or 185,750 people. So both saying the same thing, right? The second answer is a little bit less awkward. There's a second question here. It says, when will the population be 200,000 people? All right, so we need to find when, what is when? When is going to be how many, some number of years after the year 2000. So what are we solving for here? T. When is going to be the T, right? We'll add it to 2000 to find the year. Well, if then when is the T, it's T that we're solving for. We know that the population is 200,000. So our equation is going to say 200 equals 0.07 T squared plus 4D plus 110, and we want to solve for the T. Okay? It's not set equal to 0, so let's set equal to 0 first. Subtract that 200 from both sides. So then 0 equals 0.07 T squared plus 4T minus 90. Okay, and I'm not even going to try and factor that one because of the decimal here. I think I'm just going to use the quadratic formula here. The quadratic formula A is equal to 0.07, B is equal to 4, and C is equal to negative 90. Okay, we'll use that quadratic formula. So then T, our variable, T this time instead of X, T is going to equal negative B, so that'll be negative 4 plus or minus the square root of B squared, so that's 4 squared, minus 4AC, 4 times A, in this case is 0.07, and C is negative 90, all over 2A, that's 2 times 0.07. All right, when we simplify that, we have negative 4 plus or minus the square root of 16. I'll write that. And then let's put this on the calculator and just get our root. So 4 squared, that's 16, or I'll just type the whole thing in. 4 squared minus 4 times 0.07 times negative 90. There it is, 41.2. All over 2 times 0.07, that's going to be 0.14. All right, now we're going to have two values here, right? Negative 4 plus square root of 41.2 over 0.14, and negative 4 minus the square root of 41.2 over 0.14. All right, so let's find negative 4 minus first. So let's see what that is. Negative 4 minus, let's put it here. All right, negative 4 minus the square root of 41.2. Press enter, and then divided by 0.14 is negative 74.4. All right, wait a minute. Can this be right? We want a population. When will the population be 200,000 negative? Can T be negative 74.4? That'd be way before the year 2000. So I don't think that one's making sense. That one gets thrown out. Doesn't fit the context, right? Let's do the plus. Negative 4 plus the square root of 41.2, press enter, divided by 0.14. And we see the second solution we get is 17 point, we'll say 17.3, we'll round that a little bit. 17.3, 17 point. This makes more sense, doesn't it? When will the population reach 200,000? Well, it's going to reach it 17.3 years after the year 2000, right? I could do a couple of things here. I could say it's, my paper right there, I could say it's 17.3 years after the year 2000, or I could do this. I could say that it's the year 2017 and 0.3. Let's see what that 0.3 months. That's going to be, if there's 12 months in a year, if 0.3 of a year, it's going to be 0.3, 0.12, or 3.6 months. So it's going to be in the year 2017. It's going to be 3.6 months in. All right, this ends the lecture for quadratic equations.